So now it's time to introduce the man and the legend that is Dr. Michael Shermer. Dr. Shermer, if you don't already know, is an experimental psychologist and a historian of science. He is the founding publisher of Skeptic magazine and the executive director of the Skeptic Society. I've got a very long list of stuff here, so bear with me. He is a columnist for Scientific American and an adjunct professor at Chapman University. He is the host of the Skeptic Distinguished Science Lecture Series at Caltech, and he has had many appearances on such shows as The Colbert Report, Dateline, 2020, and Larry King Live, and that's just a small number of the programs that he's been on. His latest book is actually Skeptic, which is a collection of articles from the magazine that he is in charge of. But this evening, what we're going to be talking about are some of the subjects that he covered in his 2015 book, The Moral Arc. So please join me in welcoming Dr. Michael Shermer.
Thank you, Graham.
Thanks for coming. All right. Please have a seat. And you brought your book as well. Well done.
I just happened to have.
Yeah, it's amazing. Yeah.
Operators are standing by.
Available in all fine bookstores.
Yes, right.
Yes, yeah. Fabulous. Well, thank you very much for coming.
Oh, well, thank you for having me.
It's been a pleasure hanging out with you all day.
It's a great day.
We've been having a giggle. But one of the things that first drew my attention to the work that you did was when I started seeing descriptions of why people's brains are wired in a particular way to seek out patterns. And so I wanted to first get your take on what it is about the human brain that actually likes to pick out patterns in various things, because in astronomy we see patterns in the stars, we see faces on Mars, we saw some examples of smiling, happy galaxies,
yes.
and even a Veil nebula, which looks like a very grumpy person.
You had the happy face on Mars, too.
Yes, the happy face on Mars.
Well, there's a happy face on Mars, but the famous face on Mars, that was photographed by the Viking spacecraft before it landed. And the UFO people got very excited about this and petitioned NASA and JPL to take a close-up of it. And so they did with the Mars survey spacecraft in 2000, and up close it's just an eroded mountain. But if you squint, you can kind of see the face again. And so what the squinting does is it reduces the granularity of the photograph back to sort of the gross features of sort of two eyes and a slash, which is all you need to get the little fusiform gyrus in your temporal lobes right about here, which is where your facial recognition software is located. Seriously, we know this because people that have damage in this area can't see faces. They're face blind. Stroke or injury or just some problem, neurological problem with that area, to the point where they sometimes can't even recognize themselves in the mirror. So this tells us that patterns of pretty much anything are processed by the brain by roughly 80 billion neurons with 1,000 connections with each of them, so trillions of interconnections, allows us the capacity to see every angle, every line, every face. There's the famous grandmother neuron, which if you show people different faces, this one neuron will only fire if it's their grandmother. Not your grandmother, but just their grandmother. There's another one called the Clinton neuron. Back in the 90s when this research was done, there was a neuron that they found in an epileptic patient. The way these are done you can't get permission from ethics committees to do open brain surgery just for fun.
Weird.
Just to map brains. So
I couldn't imagine why.
They get the permission of patients that are going under surgery for epileptic seizures, where they cut the corpus callosum, or they go in and they plant electrodes to measure where the seizures are starting and spreading, so they can kill just those neurons and not the other ones you might need. But once you cut through all the stuff and get to the brain, it doesn't feel any more pain, so you can wake the patient up. You ask them permission for this ahead of time. And amazingly, they volunteer. There's quite a few patients that have done this, which is the primary way that we've mapped the brain is through these surgeries. Anyway, so you can do that and poke around in there, and they found one where this one neuron only fired when they showed this person pictures of Clinton. And the Monica neuron was really close, but no, just... But this process of what I call patternicity, the tendency to find meaningful patterns in both meaningful and meaningless noise. This is just learning. It's just association psychology. It's just associating A with B and finding some sort of connection, whether it's visual or sound or any kind of pattern. And it couldn't get any more basic than that. It's just all organisms do it. You have to do it to survive. And so the problem is of course, you can't be sure that you've got the right pattern because there's not enough processing power to do that. And also the sort of cost-benefit analysis of making snap decisions about which patterns are real or which are not. So my thought experiment in the believing brain was that if you imagine you're a hominid on the plains of Africa 3.5 million years ago, and your name is Lucy. Yeah, thank you. See, a few people get that. In the Midwest, they don't get this at all. What? Lucy? And you hear a rustle in the grass. Is it a dangerous predator or is it just the wind? So if you assume that the rustle in the grass is a dangerous predator and it's just the wind, that's a type 1 error, a false positive. You thought A was connected to B and they're not connected. But that's a relatively low-cost error to make. And that's the kind of error you see on these fur, fin, and feather channels where their animals are pretty skittish and risk-averse. But if you assume that the rustle in the grass is just the wind and it's a dangerous predator, you're lunch. Congratulations, you've just been given a Darwin Award for taking yourself out of the gene pool early before reproducing. And but now why can't you just stay in the grass and collect more data until you know for sure whether it's a dangerous predator or just the wind? And the answer is that predators don't wait around for prey animals to collect more data about them. That's why they're stealthy and they sneak up and they're camouflaged and so on. So, in general, animals are mostly risk-averse in the calculation of it's easier to make a type 1 error than a type 2 error. And so our tendency then is just to assume most patterns are real, just in case they might be. And so it's not that people believe weird things because they're dumb or uneducated or they're Republican, whatever. Sorry, that's too easy. That's too easy.
Keep going. No.
Apparently this is okay here. Again, different than the Midwest. It's that our brains are just wired to just assume that most of the patterns we see are real. So superstitions, as Skinner showed, you just randomly assign some kind of stimulus with a reward behavior and a behavior that's rewarded in an organism, and it just repeats the behavior. And whether it's pigeons pecking a key or rats pressing a bar or humans pulling a slot machine, they find some meaningful pattern. Lots of research on this. You can give subjects, random sequences of dots on the screen or blips in earphones, and they will find a pattern. Mm-hmm. It's why Jobs had to change the random mode on your iTunes program because people were complaining, these aren't random. These songs keep coming up in certain patterns. And it's like, okay, we'll make it non-random so people will think it's random.
Right.
Because we find these patterns. And randomness actually doesn't look like our intuitions of what randomness should look like. Because streaks and duplicates happen a lot in randomness.
Yeah, so speaking of streaks, one of the interesting things that happened when people first started using telescopes to stare intently at Mars is because these telescopes were still quite, low technology compared to what we have now, people were reporting seeing canals on Mars.
Right.
And of course we now know that there aren't. But one of the things that tickles me is this seems to have sparked almost an entire genre of literature and film, is the thought that there could be some kind of life on Mars. So what is it that may have caused people to see canals on Mars?
Well, Carl Sagan talks about that a little bit, but since he talked about that, there was a paper that was published in which somebody thought that the blood vessels in the eye, when you stare into it, you get the little floaters in your eye anyway, and that they might have been in a way that made it look like you were seeing, if you stare long enough, that maybe the canals were actually in the people's retina. I don't know if this paper was ever replicated. I remember that came out late 90s. I'm not sure whatever happened with that. But the problem is the same one Galileo had when he was looking at Saturn. So it's a problem of theory and data. So there was no theory of planetary rings. So you can't see rings that if you don't even know about rings. If the data is also pretty blurry and you can't quite make it out. So when he looked at the moon and saw mountains on the moon casting shadows, that was a challenge to the Aristotelian view of all objects in space are perfectly round and perfectly smooth. And then, of course, the phases of Venus, sunspots, the sun is marred with these spots. Okay, so he found all these things, but and the moons of Jupiter you can see pretty clear. They're quite distinct, and if you go out a couple hours later, you can see that they've moved. You can see that with just a small telescope. But Saturn is twice as far away as Jupiter, right? And
yes.
Oh yeah, that's right. You're a galaxy man. That's right. You don't know about planets. And also this telescope was pretty crude, so the data was coarse grained, not so good. Sort of looking at this thing, and it looks like it's like oblong, it's sort of bulgy, or maybe it has ears. He once said it looks like it has ears on the side, like Marco Rubio's. No.
Or a child's beaker, perhaps, yes.
And so he concluded that, he said in Latin, I have observed Saturn is 3 bodies. And that's what he concluded. And so he concluded that it was 1 large body and 2 that were, around it. And that was 1611, 1614, right around there. And it wasn't until Christian Huygens figured it out in 1655 what it was, because by then they had a theory of planetary rings and a better telescope to see. But Galileo went to his grave not really knowing that. And then later, in 1637, in the Sunspots book, he writes about, I went back and I looked, and it looked completely different. So have I been hallucinating, or no, I can't be. I'm pretty sure. I know I saw 3. I wasn't smoking anything. I mean, he was
probably.
So he had made up his mind that it was 3 objects years before, and even though new data came in, that he realized this is not matching the old model I have.
Right.
But I'm pretty sure I was right. And so he stuck with that. So that's the problem of data and theory. So here's always the problem in things that we investigate for a skeptic is when you can't quite make out what you're talking about. What is it again? That's when, and then everybody has data, but you're just interpreting it through whatever you want to.
Right.
So I remember we had a guy that was doing Michael Bailey, who was doing research on the gay gene, and gay brains are different than straight brains. This was the late 90s, and he had a paper out about this, about the hippocampus, and that gay guys' hippocampus cells were slightly different than straight guys' hippocampus cells. Okay, and he put these slides up, and he's like, you can clearly see here the difference, and everybody in the room's like, I don't see it. It's like, oh, no, look, this one. And it's like, I don't know. And that was never replicated, that one.
Good.
It's just one of those things where if you can't quite make out, then people think they see what they see and others don't, which is why we need peer review, which is why we need people to criticize us, which is why if you think Einstein was wrong, before you announce this to the world, ask somebody like Dan, I might be wrong. Can you tell me if I've gone off the deep end? This is the problem with these alternative theories of physics. Right. They work in isolation and their imaginations are running wild.
It happens more often than you may think.
Oh, I'm sure you must get these.
So we'll probably return to speaking about Mars a little bit later, but you were mentioning people potentially see things slightly differently. One thing that everybody sees almost the same is the constellations themselves. Anybody can stand outside on a dark night and see the constellations. And I was reading, it must have been some website, but they were insinuating that the pattern recognition that we see from constellations could have been used to help humanity move from a hunter-gatherer to a kind of agrarian society. But I couldn't find a citation or a peer review piece of paper to support that hypothesis. So I was wondering if you had, with your background in the history of science, whether you had any
There are some ideas about this with the Babylonians and the Egyptians that all astronomical observations had some practical value of just tracking and recording the seasons for very practical uses, not just religious or the gods are coming or the end of the world. More just like when are the rains coming, finding the patterns of weather and climate, something like that. There's a guy, an astronomer, an archaeoastronomer, who studies these ancient sites that have like archaeological or astronomical symbols and things like that. So there is a field of this that tries to make that connection. The problem is that of putting yourself in the mind of somebody, 5,000 years ago, 4,000 years ago, imagine what they are thinking. I don't know. What's this little blob on the cave? I don't know. So we project what we think we would mean if we did that, but that doesn't mean that's what they mean. So it's difficult to do.
Right. Yeah. So one of the things that have been mulling over since a conversation we had earlier today was whether or not it's actually a benefit to humanity to be an agrarian society and to be a collective to kind of collect into cities in the first place.
Oh well, it's a trade-off for sure. We know from skeletal remains that hunter-gatherers, if you look at say hunter-gatherers 10 to 15,000 years ago, and you compare them to farmers, say 5 to 3,000 years ago, just by the skeletal remains. The hunter-gatherers are taller, they have fewer cavities, they have less rates of arthritis and joints, all indicative that their diets were more varied and better. And so, of course, the trade-off is you can't support very many people in a small hunter-gatherer community of maybe a dozen or two, and it's much more dangerous for other reasons. And so there's certain safety in numbers with larger farming communities, but there's a trade-off in that the diets they're pretty crappy. I mean, you're just eating mostly starch and not a good varied diet and not as much exercise, and also living in dense populations, you have more communicable diseases. So there's a lot more, smallpox and things like that spread through these early farming communities. So, I mean, it's not like we're going back. So here we are. We got to just keep going forward and solve the problems. But
right.
But this idea of the paleo diet. We just did a issue of Skeptic on the paleo diet. There's these myths about what's natural. If you look at ears of corn from back, they're like this big, and there's nothing we're eating that's very natural. But
right.
The idea is to try to get away from chemicals and so on. But paleo diet, there is no such thing. Our Paleolithic ancestors, they had a seafood diet. Whatever they saw, they ate. And that's pretty much it. If you lived if you lived in Santa Barbara, if I was a Paleolithic Indian, this is where I'd live. They had lobster and shellfish, and it was a really great diet.
Well, hopefully you wouldn't have been allergic, right?
Unless you're allergic, yeah. Yeah. So yeah, it's a trade-off.
Right. So let's move things on a little bit further. And one of the things that I really enjoyed about, I think it was the third chapter in your book, is when you actually started talking about the history of science in terms of the role that Newton played. And one of the things I hadn't appreciated was the influence that Descartes had on Newton's thinking, and in terms of the clockwork universe, as you put it. So I was hoping you could give me a bit more of being a non-philosopher.
Yes. And it's good to remember that the word scientist was only invented in 1833. So everybody before that was a philosopher. So this idea that philosophy is dead and science is it's all a kind of philosophy. Science being a branch of philosophy, and they were doing natural philosophy, mostly dealing in the natural world. So. After the story you know very well, of course, from Copernicus and Kepler and Galileo up to Newton, those are mostly the physical sciences. Where it gets really interesting is the impact that those discoveries had on the rest of culture, particularly after Newton got translated to the continent in French and so forth, and the idea spread that the world is knowable. That planets, we can predict them and so forth, and that it's like a clockwork universe. And so not just in the physical world, but the biological world, like the heart beats and the blood flows in a circular motion through the body, almost like a planet going around a sun. The heart was considered to be like the sun, and the organs are like planets, and the blood is like the ether and this sort of thing. And then so that this began to apply to social systems. The king is like a sun, and the people are like planets going around him, and he has all this power like gravity over them. And these metaphors were used. But what underlies that is the idea that maybe we can understand how political systems work, and economic systems and social systems, that we can study the social world in a scientific way like Newton did. So there was an interest in in sort of from Descartes through sort of Newton's contemporaries like John Locke. John Locke's treatise on two governments, this is a work of science. He was influenced by Newton and Descartes and the sort of Cartesian logic to it. We can reason our way to solving problems. There was a guy named Montesquieu, the famous Montesquieu, wrote a book called The Spirit of the Laws, Esprit de Loi. And this spirit, he means the sort of environment, the physical environment of the culture that the people live in. Not just the physical environment, the temperature, what they do for a living, the kinds of laws that they have, and so on. These are all correlated. So he had like hunters, herders, farmers, and traders. That was his typology. And this is a big book. It's a book of science, and he was a scientist. We would call him that today. And he ran little experiments when he was young, and he was trying to solve the problem of how should we structure a civil society for us to live best. Well, this is just a scientific problem. This is a problem we can try to answer, and he tried to answer that scientifically. In France, the physician to the king of France, Francois Quesnay, was a physician, and he was assigned by Louis the whichever one it was, 14, I think. 13 and 15 were bad, but 12 and 14 were great.
You can't use X.
It's right. X and it's like Rocky 1 and 3 were great, but 2 and 4 not so good. You know? Star Trek 2 and 4 were the good ones, but 1 and 3 were not. So have to keep track of those. Anyway, so he was given the job by the king to figure out how the economy works. Just the mercantilist system. Let's hoard as much stuff as we can. Maybe there's a better way. So he undertook this study, which is where the word laissez-faire comes from. It's a French word, just means leave alone. What he meant was, you know what, if we pull back and don't have too many top-down controls and let people just trade with each other, that actually builds up more wealth in our nation. And that's where Adam Smith got this idea. Adam Smith, a philosopher, moral philosopher, but just trying to solve a problem. How does wealth accumulate in a society? That's a scientific work. And so it just kind of goes on. Thomas Hobbes' Leviathan. It's probably the most influential work of political treatise in history. Political scientists will tell you this is right. This is where it all begins. He was a materialist philosopher who believed that everything begins with atoms in motion. And so he builds from this an associationist psychology, like the atoms in our brain are just moving around like planets are moving around, and ideas come in through the senses. Like Locke said, the blank slate and the brain forms these ideas from sensory input and these particles in there that are moving around. And 400 pages later, he's got a civil society with a king and laws and so on. Okay, you wouldn't want to live in the society that Hobbes built, but
yeah, I've read the book.
Yeah, but the idea is that it's an attempt to make a scientific study of morals, values, politics, economics, society, the whole thing. So that's what kind of the case I'm making is that what has science got to do with morality? I mean, it just sounds like two different things, but that's kind of how I get there.
Yeah, one thing I enjoyed was when you started to discuss the influence of the scientific method and reason on the Declaration of Independence.
Oh, yes, yeah. Right, so Jefferson, again, another great scientist. I mean, he's a philosopher, but today he would be a scientist. He did natural history, he collected fossils, he studied astronomy and so on. And these guys were all trained that way. And there were no academic barriers, like that building over there, that's where the biology people and the historians are over there, and the English people are over there. It wasn't like that. And he and Franklin interacted on this, and really the Declaration of Independence is kind of a rational argument for starting with John Locke and building from there, and making changes in there that Franklin made the little caret change, write in, little edit there, and changed it. I should find the little particular passage that he did. Oh boy, that's kind of a thick book to find stuff.
It was your fault.
Who wrote this? Yeah, I think this is at 136. Let's see. It's a good passage but I don't have it memorized. Maybe we'll find it. Oh yeah, here it is. See, the most important of his edits, Franklin's edits of Jefferson, was small but resounding. He crossed out using heavy black slashes that he often employed the last three words of Jefferson's phrase, "We hold these truths to be sacred and undeniable," and changed them to the words now enshrined in history, "We hold these truths to be self-evident." The idea of self-evident truths was one that drew less on John Locke, who was Jefferson's favored philosopher, than on the scientific determinism espoused by Isaac Newton and on the analytic empiricism of Franklin's close friend David Hume. And what became known as Hume's fork, the great Scottish philosopher, along with Leibniz and others, had developed a theory that distinguished between synthetic truths that describe matters of fact, such as London is bigger than Philadelphia, and analytic truths that are self-evident by virtue of reason and definition. The angles of a triangle equal 180 degrees, or all bachelors are unmarried. By using the word sacred, Jefferson has asserted, intentionally or not, that the principle in question, the equality of men and their endowment by their Creator with inalienable rights, was an assertion of religion. Franklin said it turned it instead into an assertion of rationality. That's a good example of that.
Yeah.
That transitional phase from religion gives us the rules of how we should live by to maybe there's a better way.
Right. And so, one of the roles that I've seen astronomy doing is replacing previous worldviews with something that's a lot more aligned with, reality.
Yes, well, one would hope.
Yes.
But reality where we actually have a human nature. There's a human nature that exists. We can discover it and figure it out what people want. And at least within the general guidelines, we're going to sort of go this direction or that direction. And some things work slightly better than others. Let's try that. Let's try this. That's why Jefferson called it the American experiment. We're experimenting. And no one knows how to run a country. So we'll just set it up this way with lots of checks and balances. And we'll just have lots of elections, which are experiments. Just sort of reset the variables and go for another 4 years and do it again. It's just never-ending process, which is what science is. It's sort of never-ending, open-ended, keep trying, keep experimenting, keep collecting data. And in a way, that's, there's 50 different states, so we have 50 different tax systems, 50 different systems of gun control laws, and so on. And each of that's an experiment. All right? Well, we want this. Let's see. Well, who else is doing? Well, those guys over there, they're doing that. Let's see how it worked. Now let's try it slightly differently and see what happens here. And those are experiments.
Yeah, and that it always helps bend the moral arc, as you say. As you
hopefully
point out.
A little bit.
Yeah.
Yes.
So one of the things that's really quite interesting in this particular era of human history is the amount of fundamental discoveries that are being made. If we turn the clock back to the early 1990s, we thought we were probably a lonely solar system in an empty universe that wasn't very interesting. And now we move it forward to 2016, and we now know that there are probably more planets in our galaxy than there are stars. We now know of the Higgs boson. We now know of dark energy. And then recently we now know of gravitational waves, the direct detection of gravitational waves. Has there ever been a time in human history where we've made such rich discoveries in such a short period of time, do you think?
Probably every generation thinks this is the biggest thing that ever happened.
Fire!
Yeah, fire, good. Yeah. So I don't know. Probably, but maybe in from 2050 to 2100, it'll be even better, and we'll miss out. So let's just say ours is the most important because we're here.
Yeah, we'll take credit. Yeah, I mean it must have been quite a while between fire and the wheel, for example.
Yes.
So
yes.
Yeah.
I do think it shows furthermore to what extent we can understand the world further and further out using science, leaving religion less and less turf to cover. Not that we can explain everything, but the fact that we can explain more and more and more. It's a little bit like the crop circle phenomenon, which was mysterious for a while until those guys came out in England and said, well, we did it. Here's the videotape. Oh.
And still there were people that doubted it.
Still people said, yeah, but okay, that only explains 95% of the crop circle. Right. These over here are the real ones, and those guys were copying the aliens' crop. Okay. What's more likely? So this is called the residue problem in science. There's always a residue of unexplained anomalies in any particular area you're studying. So what do you do with them? Nothing, or you assign them to graduate students to work out. They got to do something. And in the meantime, you don't have to construct a whole new worldview based on, well, I can't explain this one thing over here. Like the UFO people, the hardcore believers, and myself, we're only different by 5%. The serious ones will admit, I know, 95% of all the sightings we have prosaic explanations for. It was Venus, or swamp gas, or whatever. And so, but what about this one in New Mexico? Blah, blah, it's like, I don't know.
Yeah.
But the fact that I don't know doesn't mean there's a whole new worldview. There's aliens are here, the government's covering it up, and on and it's okay to just say, I don't know.
Yeah. Oh, yeah. We ignore outliers, or that's what we try and do. But sometimes those outliers actually draw the most attention. And I think we see that in the political system right now.
And it's okay to give them attention. Again, graduate students, they got to work. If you want to get your degree, you got to do something new, slightly new. So you just go in that direction. That's fine.
Yeah.
But in the meantime, it's okay to say, well, we don't know that yet. And that's one of the psychology. People have a hard time. Most of us have a hard time just being comfortable with I don't know. It's more comfortable to fill in the blanks. It reduces anxiety and terror or whatever of the unknown.
Yeah, because it is an uncomfortable feeling. That the further I get through my career, the more I realize that I don't know, or the more I start to doubt what I think I know, and it's not a pleasant feeling at all. So I can totally sympathize with people going, right, I want this to be true. I'm going to go after this and really put all of my chips on that, even though it could be completely crazy. Yeah. Yeah.
There's the Planck problem in the history of science when Max Planck said. I forget what the exact wording was, but it was basically a history proceeds by funeral. For the new paradigm to be accepted, the old Turks have to be gone. And there's some truth to that. There's a correlation between age and resistance to change, basically because of cognitive dissonance. The more committed you are behaviorally, financially, psychologically to an idea, a belief, a theory, a paradigm, religion, political, whatever, the harder it is to change. That's true. Still, it happens. People change their minds.
Well, so one of the excellent examples in astronomy of this is the relationship that Tycho Brahe had to Johannes Kepler, because they were PhD advisor and student. And it's either a very strange coincidence, or Kepler waited until the year after his PhD supervisor's death in order to publish Kepler's laws, which basically say that the planets are not in perfect circles. If you make them elliptical, then you can explain all of the really high precision data that Tycho Brahe came up with.
Yeah.
So
I'm not sure about. I'll have to look that up to see if there's anything new about that. The timing on that, but of course planets do travel in ellipses. So presumably somebody would have figured that out, given that's the way it really is.
Right.
And we can assume the same is true with biological systems and social systems. There probably really is a way the world really is. And we can figure it out if we work at it hard enough, which is the beauty of science versus other forms of knowledge, whatever those are.
Right. Yeah.
I can't think of what that would be.
Other forms of knowledge, yeah. Towards the end of the book, you start talking about what the future actually may hold. So, in a talk about the history of science, we can talk about what the effect of that may have in going forward in terms of human development. And so there's a couple of ideas in here about the types of societies or civilizations that we might be having. And I was particularly happy to see you explaining the Dyson sphere, actually.
Oh, yes. Well, the future. Forget flying cars. Electric cars. Let's just get there first.
Yeah. Baby steps.
And then self-driving cars that don't crash. And so I call this Protopia. Kevin Kelly, the founder of Wired magazine, he's one of these sort of futurist technology people. And so Protopia is not utopia, which it doesn't exist, or dystopia, where we're all going to hell, but just Protopia, small little micro steps of progress. Today's a little bit better than yesterday. The next year's car model nav system is slightly better than this year's car model nav system, because this year shows the traffic pattern in last year's. Just this little incremental thing. And cumulatively, it really does cause the moral arc to curve quite a bit. given enough time. So I thought, I just sort of played around at the end of the book of, type 1, type 2, type 3 civilizations, a favorite idea in science fiction, but one possibly true in science fact, that, if you want to capture the energy, a renewable energy of a solar system that's from the sun, so you build a sphere around it, or at least something that captures more of the solar. We could just start with, like in California or Florida, there's a lot of sunshine, and there's a lot of empty space with no solar panels. So there's a good place to start. And then just take that principle out. And to get to be a type 2 civilization, you have to have a sustainable source of energy. Fossil fuels won't do it. And so, then you end up, and that's an old idea, actually. It goes back to like the 1930s. I think Olaf Stapleton was the first, before Dyson, to come up with that idea, capturing all the energy of the sun. And by the way, there's a finding, star KIC, it's like 5 digits.
1, 2, 3, 4, 5, 6, 7.
Yeah, 1, 2, 3, 4, 5, 6. That has an anomalous dip in light. It's like a 20% dip in light. That, as I understand it, there's no natural explanation, like a swarm of comets that going around it, or...
No, that is the natural.
Oh, that is the... Yeah. Is that the preferred one now?
Something like that.
Something like comets?
Yes.
Well, as you can imagine, in my world, that is rejected promptly, for aliens did it.
Yes.
And that it's something like a partial Dyson sphere that goes around the sun, something like that.
Yeah. That was what's created the excitement about that data. That was the first thing that the media grabbed onto was...
Yes, aliens, yeah. In fact, I was on this radio show in Los Angeles. Let's see, was it Rob and Jillian? Okay, so it's daytime talk. It's one of those, they sort of just chit-chat and make light of things. So they had me on to talk about the goofy stuff. Not this, but the aliens and things like that. Anyway, so they had George Norrie on, who took the place of Art Bell in that coast to coast AM that goes from midnight to 5 a.m. Let me tell you, there's no better time to listen to talk radio to hear the real wackos are out, staying up all night, and let's go to Bob on Interstate 10. I saw this light come up over my truck. Oh boy. Anyway, so George has a new show out, and so he was promoting the show, and I was on for something else, and so he brought up this KIC thing, and he said, I have an insider friend at NASA that tells me it's a greater than 50-50 probability that it's aliens. And, I said, well, who is this friend? Because I know people at NASA and JPL. And, I can't say.
Yeah.
So I said, well, I have a friend that tells me it's less than 1%, and I can't tell who it is that's telling me. But then the host, Jillian, she says, well, what are they like? And I said, what is who like? She went, the aliens. I went, no.
Wait a minute.
No. What are they like? What?
You've clearly met them.
How did we get there? The next question.
Yeah.
I mean, this is what we're dealing with, really. In the real world, outside of, the halls of, this is what it's like. I mean, people just believe this stuff.
Yeah, because ironically, in the scientific community, we love this stuff. I don't know means somebody's going to get a PhD dissertation.
Yeah, that's right.
Yeah. So, no, the data from this, whatever it turns out to be, it's very, very exciting stuff. So one of the things that we've recently started doing here at Florida Tech is working on the really quite difficult issue of getting a sustainable human colony on the surface of Mars, and we've been working with Buzz Aldrin on this. And one of the things that I really didn't appreciate on this problem was the issue of humans and the way humans are going to have to interact in that kind of environment. So I wanted to spend the last couple of minutes actually talking about what your thoughts are on this type of issues that we're going to be having with a society that is entirely remote and cut off from Earth and all of the support that Earth has. At the moment, we're assuming that the humans that go on this mission are all going to be somehow selected to be perfect. And that's clearly not going to be the case.
Well, I assume NASA has teams of psychologists that study this stuff. I mean, we have lots of natural experiments that have happened over the centuries, small little utopian communities, for example, that form. I mean, they almost always fail, in part because their political system doesn't really work, but mostly because just personality conflicts. People just have a really hard time getting along. I mean, just look at families just dysfunctional is, a pretty common adjective. So that's a serious problem. No matter how serious they are, well-trained, professional, and so on, that to me will be as big a problem as radiation or whatever the other, long-term space flight without doing the exercises to overcome the gravity-less environment and all that stuff. All those problems, the psychology is going to be an issue. Still, it's doable, for sure. I mean, people have survived, long stretches on expeditions to the poles and things like that.
Right, and that's where a lot of what we call the analog research is done, is send people to the middle of nowhere and lock them in a cabin. See if they hurt one another, basically.
Yeah, well, that's right, and sometimes they do. The Biosphere 2 group, they got along fairly well, but they had other issues of diet. I mean, they weren't eating enough, and they didn't get enough oxygen, and they just couldn't do it.
Yeah.
The Biosphere 1 is big enough, the Earth.
That's how they named it.
Yeah, that's where it came from.
Right. Yeah, the sustainability issue is another big deal for Mars as well, because it actually affects how you have to design your mission. How much stuff do you have to take with you, and how much stuff can you generate once you get there?
Yeah.
So this is,
Well, send it ahead of time.
Well, yeah, there are many ways to do it, and Andy Weir spent a lot of time obviously thinking about this, and that is one very expensive way of doing it. Yeah, but one of the other things, of course, is you can't just send people to Mars and go, there you go. You have to give them something to do.
Yes.
And so, what are the types of things do you think that people could be doing? The types of activities that colonists could be getting up to?
Besides growing potatoes?
Right, yeah.
I would love to live long enough to see this happen, just to see if there's just a permanent colony, what kind of political system, economic system, social system, moral system develops, presumably without religion, just as kind of an experiment. Now, maybe it would happen anyway because some of the people are religious, but it would be interesting to see if it's just we're just going to set it up as a rational system. You start with 10 people, and then 100, and then 1,000, and the rules change as the numbers get larger. You have to have different social, political, economic systems with larger numbers and smaller numbers. So it would be interesting to see how that evolves in another completely different environment.
Right.
That alone would give people plenty to do and fight about.
I mean, is there actually any sense of what type of numbers you need in order for there to be a community that is not going to be entirely dysfunctional because there's too few people and personality clashes are not too big that it becomes a lot more difficult to sustain, or you start ending up with splinter groups and things like this that then could start?
Well, we know from anthropologist studies of like the Yanomamo people in Brazil, they splinter off after about 100 to 150 individuals. And then they break, because their style of living, hunting, gathering, and a little bit of farming, a little bit of gardening, can't sustain more than that many. You just can't feed that many bodies. So they break off and move. And that's true in our hunter-gatherer ancestors. The numbers, a couple of dozen to a couple hundred tops, that a hunting-gathering lifestyle can support. There's just only so many grubs to eat and animals to catch. So
not on Mars.
On Mars, yeah, it's a different kind of problem.
Right. Yeah.
So you would really need. It would depend on the energy capture for everything.
Right.
Including and especially food, and it could only expand if you were able to capture more energy and put it into growing food and things like that. So as for meat, there's a company called Memphis Meats.
Yum.
Yeah. And they're growing synthetic beef. This guy is a cardiologist who was doing research on planting stem cells in patients that had heart attacks to grow the meat. It's meat, your heart's meat, and to grow new cells. So he thought, well, why can't I just grow it in a test tube and eat it? So this is a company that's trying to do this. It's more of a moral issue for them, end factory farming, which is pretty gruesome. But in the long run, something like this, we can't take cows to Mars, but you could, in principle, take synthetic meat and grow it if you have the energy to do it. Right,
because we want to have the hunter-gatherer body, right?
meat. It tastes good.
Yeah, yeah, yeah.
I don't like the factory farming thing, but it's hard to get off of it completely.
But it kind of speaks to the point of kind of removing the romanticism about a mission to Mars. Is that there are gonna have to be people there to support the people that are doing the science, basically, that's on Mars. I mean, you can't just send 6 people and expect, well, as we saw, you can't just send 6 people, because if you lose one of them, you've just lost a crucial skill set, right? Whatever that person was carrying.
Right.
But in a society of 50 people, there are going to be 10 people that are really annoyed with the job that they have.
Yeah.
Because it's going to be doing something really disgusting.
Yeah. Yeah.
Yeah. So you could start to see where.
Well, hunter-gatherer communities are pretty egalitarian, and there's not a lot of wealth. There's not a lot of stuff to hoard. So everybody has pretty much what everybody else has, and everybody knows what everybody has. So it's a pretty transparent, open society. Once you transition to thousands of people in these early state societies, that's where you start to get the disparities and hierarchical social structures. And it becomes rigged, and the people at the top are getting more than the people at the bottom, and we've been on this trajectory for 10,000 years. Is this inevitable? I don't know. I mean, this would be an interesting experiment. There's a group called the Seasteaders. It's the other, his name escapes me, the other, besides Elon Musk, the other PayPal guy. It'll come to me in a minute. But anyway, he's funding seasteading. Seasteading is where we start our own new society, a country. Out in the ocean, you just have a floating platform. And they're like units you plug in, and you just keep growing it. People move in, you just plug your unit in, you're just floating out there. This hasn't happened yet, so don't sign up. But
somebody will already.
Yeah, it's like who wants to be the early adopter on that?
Right. Right.
In addition to just the regular provisioning it, what about pirates or just people that go, I hereby take over your seastead nation?
Well, people are willing to back these types of things on a promise. I mean, we see this with the Mars One project. It's essentially a project that's going nowhere, but people are still putting their money into it. Yeah. So.
But if somebody did this, say off the coast of California or Mexico or something, they were talking about Mexico, I think, as the first place to start, and you had a dozen people, and then 50, and then 100 or 200. It would be interesting to see what would happen.
Yeah.
Could they do it without having to go back to the States and get their stuff, buy more food and provisions?
Right.
Could you do it like a biosphere too, where it's completely isolated? Very, very difficult.
Yeah. So one of the things that got me into the astronomy career was watching an awful lot of Star Trek.
Star Trek, yes.
And there's no shame in that. The Next Generation. There isn't anything else. But
Wait a minute. Captain Kirk or Picard? Come on.
Well, who is more? Who has
the girls?
Who has the moral? Who has the moral superiority of the two?
Yes. Okay. Well.
Yes. Yeah. So one of the very last things you speak to in the book is going back to what you mentioned earlier, this protopia versus utopia. And of course, everybody naturally assumes that utopia would be the best thing. But you explained quite clearly, why a protopia is a much more reasonable thing to aim for. And I was wondering how the utopia-protopia thoughts actually apply to the Star Trek universe itself.
Oh, well...
where they have a united federation of planets, and they have these prime directives, and etc.
They get violated every week.
Yeah.
Well, I was just, the problem with utopias, the word itself means nowhere, which is what Thomas More meant, is that it's unattainable. It's the idea of we can achieve, perfect happiness forever for everybody. And the problem with that is that, in addition to you can't. Then
there's no hope.
But as there's obstacles along the way, it's like, how come we're not achieving our steps toward our utopia? Oh, it's because of those guys over there. They're not on board with our program. Well, what are we going to do with them? Well, okay, so you know about the famous trolley experiment. Pretty much everybody. But if you've been on Mars for the last decade, you know about the trolley experiment. So trolleys hurling down the tracks, about to kill these 5 workers, and you're standing there, and you can pull this switch, and it diverts the trolley down a side track where it kills 1 worker. It's one of these thought experiments, where you're not allowed to go, get up, there's a trolley coming.
Yeah.
There's no alternatives, right? So, so almost everybody in these thought experiments says, well, of course I'd pull the switch, and I'd kill 1 worker to save the 5, kill the 1 to save the 5, a simple moral calculation. The numbers change when you say, the trolley's hurling down the track, there's a bridge over the track, and there's a big guy standing on the bridge, and if you throw him off and he lands on the track and the trolley smacks into him and kills him, but it saves the 5 workers, would you do it? That's harder for people to do because it involves actively killing somebody versus passively letting it happen. Anyway, there's a whole psychology behind that. But the point is that most people say they would be willing to sacrifice the few to save the many. So people are intuitively utilitarians doing that kind of calculus. And this is the basis of genocides. This is what we want, and we know this is the best society that we can have, whether it's truly utopian or whatever. But these people over here are the ones that are keeping us from getting that. How evil are they? You do the math, okay? The math is kill the few to save the many. Kill these over here to save this big group here. That seems acceptable. Now, of course, it's not. It's illegal. If you were a doctor that sacrificed 1 healthy patient to save your 5 patients, you'd go to jail for murder. You can't do it. So our legal system tracks a real, non-utilitarian moral system. But this is the problem with utopias, is they lead to that. And you can see it historically, particularly in like Marxist states and Maoist, Mao's China and so on. These are the people, Cambodian, the intellectuals or the Hutus and the Tutsis, they're stopping us from achieving our goals. And that would be something that worries me about any kind of system that anybody sets up somewhere.
Right, yeah. Well, one of the frequent counterpoints I hear to that argument is, what if there was one of those people that you saved turned out to be the next choose your famous historical
yes.
Nasty person. So then you actually tip the balance of that dilemma, because you can't predict how somebody's going to behave in the future.
Of course, the so-called pro-lifers argue, well, what if the aborted baby would have turned out to be Shakespeare, and then they have examples of people that. Well, what if the mother who died in childhood would have gone on to become a doctor and save lives?
Yeah.
Instead, she died in childbirth. You can play that, in that game, and that's a good comeback for that argument that's often used. So, yeah, those kinds of calculations this is what leads people to take extreme actions. Why we can't allow that. So again, moral progress, just little steps. Let's just try that just a little bit and see how it goes.
And of course, if you're a Vulcan, you take the ultimate step and remove the choice and actually sacrifice yourself.
Oh, is that what Vulcans do?
Yeah. I think that's a good point to leave our discussion and turn it over to the audience. So please all join me in thanking Dr. Shermer.
Thank you. It all starts with Star Trek.
Yeah, and ends there. All right, as I mentioned at the beginning, we have 2 microphones down the front of the stage. I'd encourage anyone who would like to come up and ask us anything to please form an orderly line and make sure you are not going to go off on a monologue when you get down here. Who's going to go first? Nobody?
I wrote it down. This has to do with your expertise in neuroscience and moral philosophy, and regarding advancements in medications, gene manipulation, cybernetic augmentation. I was wondering if you have any suspicions about a big next step. And do you think that natural selection will simply run its course, or do you see kind of our knowledge overstepping that and us taking the reins ourselves? And do you have any opinions on whether or not we can reach those ends ethically, or will it be maybe just as brutal as it has been in medical science in the past? And I'll take my answer off.
That's a great question. That's a huge
Sounds like a book.
Yeah, You know, that could be my next book. Well, okay, so first of all, there's still some evolution going on in human societies. There's been recent research on just gene changes in populations over the last 5,000 years, for example. So it's not like the whole thing stopped after agriculture was started. But that said, of course, we have and are continuing to try to take over control from nature and run our own biology. And I think that's a good thing. Now, some of the stuff you hinted on, I think, was on artificial intelligence. That is, to what extent can we, like we do with our joints and hearts and lungs and so on, augment the brain? And there are a lot of people working on this, huge steps of progress on that. Cochlear implants, that's kind of a brain implant in a way. It goes in there. And, there's that guy, there's now a couple patients that are quadriplegics that have chips in their brains, and they can run their computers just by thinking. The chips are in the motor neurons, so they're trained to just think certain thoughts, and it causes the cursor to move. And it's just a biofeedback thing, and it's quite doable. And so now this is an interesting sidebar on the paranormal. If you didn't know about the chip, it looks like it's telekinesis. He's just thinking this thought, and the computer's doing things. He could turn on music. It's like, whoa, he's thinking these thoughts, and wow, he's psychic.
Clearly.
This is Clarke's third law. Any sufficiently advanced technology is indistinguishable from magic. It looks like magic, but if you know he's got a chip in his brain, it's technology. And that's where we're going. Now, the singularitarians, Ray Kurzweil and the sort of super optimistic AI people think that it's within our lifetime, 2030 to 2040. I think they're overly optimistic on that. That is when computers achieve human-level intelligence. We did an issue on this, by the way, in the 90s. We concluded that we're 5 years away and always will be. It's one of those, when I was in college, I was asking questions like, those were the kinds of things on the table then. And so I think it's a harder problem than we think, but I think it's doable. To the point, I'm not sure where uploading the brain, you know about brain uploading, where you scan every single neural connection in the brain. It would be a huge database. It's like more than all the data storage in the world today for a single brain, a lot more. But still, Moore's law keeps going, and then you upload it into a computer, and then it's you. It's like Johnny Depp in Transcendent. It's you, or is it you? See, it's not clear to me that. So you mentioned philosophy, the problem of identity. I'm not sure that it's you. When you go to sleep tonight, you wake up in the morning, you're a little groggy, but there's a continuity. It's like, oh yeah, I'm still me. And you go under general anesthesia, you're out for an hour or two, and you wake up, you're a little groggy, but it's still you. There's a continuity. But if you kill the brain, scan it all, put it in a computer and turn it on, do you wake up, or is it just a copy of you, and it's just a copy, like a twin?
Yeah, I mean, there's loads of science fiction that talks about this.
Yes.
This is one of the there's obviously going back to Star Trek, the Borg, right? We don't want to go there, right? And then when you end up with the type of computers that can reason like this, you end up with the 2001 situation, right, where the HAL 9000 is realizing that actually to get the mission done, he needs to
kill.
He
needs to. Yeah, it's the utilitarian trolley problem for HAL. I hadn't thought of that. That's a good way to think about that. So, there's at edge.org, John Brockman's site that he runs with the annual questions that he gives all his authors. Last year's was something like, what do you think about machines that can think? So it was pretty much everybody who's in the AI field wrote a 700-word essay about this. It's a great, if you want to know what everybody's thinking about this, from most pessimistic to most optimistic and everything in between. I think, again, the fact that there's so much diversity of opinion about where this is going, we have a ways to go.
Yeah. All right. Do we have a question down here?
Hello. I just wanted to ask you a question about a topic we didn't really cover, climate change and climate change deniers. And I was wondering how you personally would approach a climate change denier, or someone who is what we like to call a layman, in level-headedly, so they don't get frustrated, or you don't get frustrated because of what you consider to be obvious to you, but just maybe a 5-minute description of how to explain how it's obvious and how to educate them.
Yep. So how do you deal with climate deniers or climate skeptics? Because I used to be one. And so that's one way to start. You can say, well, yeah, I used to be skeptical of all that. You did? What happened? I read the papers. Oh, okay. Not the newspapers, the actual article.
Yeah.
But even that's a little snarky. So here's the problem, is that almost everybody's pro-science. The anti-science part comes about if the perception is that the science challenges somebody's sacred values, whatever the sacred value is. So if it's your religion, for example, and you perceive Darwin's theory of evolution to be threatening to your sacred value to the point where you have to give it up, people are not going to give up a sacred value for this little thing over here, Darwinian evolution. Who cares? This is super important to me. And for climate people, it's the same kind of thing. For them, the sacred value is free markets and business and pro-capitalism and so on. And the perception is that if global warming is real, that means the fanatics are going to get in there and tinker with the economics of industry and put caps on trade, and before you know it, they're going to be controlling all business, and we're all going to be socialists. I mean, they get there almost as fast as I just said it, from those steps, and that is what they think, and so but you can't say that, or even maybe you don't think it consciously, so you go after what the data is. I doubt the data. The Merchants of Doubt is a great book by Naomi Oreskes, and the film that Robbie Kenner made based on the book called Merchants of Doubt is very good in this regard. And it's not just about climate, it's about cigarette smoking, and there's all these, and chemical retardants, fire retardants, and how all these industries set up these faux science groups. Science for the people, science for families. Don't you believe in families? Freedom, yeah. Don't you believe in freedom? And then
You could run for president.
Yeah, see, I could do it.
Yeah.
But of course, they're just front groups to protect an industry, and this stuff usually comes out. The famous memo is, doubt is our product. It was a PR company for the tobacco companies that was hired to plant doubt to deal with the problem of cigarettes causing cancer. And then about a decade later, as Kenner tracks in this film, Merchants of Doubt, that there was sort of a flurry of home fires caused by cigarettes. People fall asleep, cigarette falls on the couch or the bed, people's clothing catches on fire, cigarettes. And so the solution was, hey, don't smoke in bed. Don't smoke in your jammies and fall asleep. No, the problem is we must surround the cigarette with fire retardant materials. And this they did. They got these science front groups to get government to pass laws about furniture, couches, clothing, pajamas, carpeting, drapes have to have all these chemicals in them. Of course, the chemical industry ate this up. And then now the climate. Okay, so but the amazing thing is that Robbie showed in this film, it's the same people, not just the same arguments, but the same scientists testifying on behalf of cigarettes, chemical fire retardants, climate change. And it's all the same kind of protection of business and industry.
Well, in my experience, there's another reason why people deny things, and that's they don't want these things to come true. And obviously, climate change is going to have a fundamental impact on the way of life that we currently have. And do you think there's an element of climate change denial because people just don't want that to become a reality?
Oh, absolutely, yeah. That's right, yeah. So, so one way so you have to diffuse the fear that I have to give up this sacred value. And so I usually start by saying something, well, I used to be a creationist, I used to be a Christian, I used to be a climate skeptic. All true. And that helps, like, oh, really? So you're like me. Well, what happened? And then you just sort of work your way through the arguments and see how you got there, then maybe they come along with you. It's almost impossible to just hammer somebody and make them come around there. Cognitive dissonance kicks in. The wall goes up. Cognitive dissonance, Leon Fessinger's theory about, the more invested you are in a belief, the harder it is to give it up. In the teeth of contradictory data. Okay, his famous book on this is called When Prophecy Fails. It begins on December 21st, 1954, at the top of a mountain in Illinois, where he went with a UFO cult waiting for the mothership to come. This woman named Marion Keach had gotten voices from the aliens and told her the world's coming to an end. There's going to be a big flood on December 22nd, and so we're coming to get you. Okay, so they all go up there with their belongings, ready to go, and Leon Fessinger, a psychologist, is up there with his clipboard going, "What's going to happen when the world, presumably the world won't end? What will they do?" And so what they did was they doubled down. Well, first of all, they went, "What time have you got?" Because midnight, well, maybe it's Pacific Standard Time, and we got 2 hours to go. Maybe it was tomorrow night, and I forgot to carry the one. It's next year. Whatever the calculations were. But at some point, they just went home and doubled down on their beliefs. They became more adamant and more evangelical in their professing their beliefs. So you have, here's my belief, here's the contradictory data. So instead of going, "Oh, I guess I was wrong," you just double down and then rationalize away the data. So creationists do this, Holocaust deniers, climate deniers, everybody, they all do this. So you have to diffuse that. You don't have to give up anything. Hey, capitalism's great, free markets are great, we're going to have electric cars, we're going to have renewable energy. You're going to make a fortune on green technology. Oh.
I'm a believer.
Yeah. And then sort of work on the data. The data is quite secondary.
Yeah, good. All right, do we have another question down here?
Hi, Dr. Shermer. Cognitive dissonance may be a good lead into my question, but I'll frame it with telling you that I'm a scientific atheist and my major is psychology. So knowing that the galaxy is 5 billion years old and humans' lives on the planet are probably a bleep in history, from a personal perspective, how do you balance your worldview with finding meaning in your personal life?
Finding meaning in a personal life in a scientific worldview or an atheist worldview, secular worldview. Okay, so first of all, there is no atheist worldview. Atheism is not a thing. It's not a worldview. It's just we don't believe in God. Full stop. That's it. We're humanists, secular humanists, Enlightenment humanists, whatever the term is. Which we believe lots of things. We believe in all sorts of things: rights, civil rights, women's rights, gay rights, animal rights. We believe in civil liberties. We believe in expanding the moral sphere. We believe in the Constitution. There's lots of things we believe in, and so it's defining yourself by what you believe instead of what you don't believe is a good way to go. To start, to say, don't worry about the God stuff. This is what we believe in, and it's all good stuff. And most people do believe in those things now. Most people are children of the Enlightenment, all of us. Even Christians and so on, they will also agree with you, that people should be treated equally under the law and that people have rights and so on. They're coming around. They are. They can't help it. The momentum is there. God loves everybody, including gays. Oh, really? Now you think that? Okay, great. Because you weren't saying that 2 years ago. So hey, that's progress. And then, we do know how people find meaning and purpose in their lives. That there's studies on psychologists that study happiness. Having family and friends, a social community, having some kind of relationship, a love relationship, a partner, anything like that. Having meaningful work, just sort of purposeful, meaningful work, a reason to get up in the morning and get out and do something, even if that's charity work, whatever, job, something that you like. And then some kind of spiritual. So here it gets a little fuzzy. Some kind of spiritual. It's such a fuzzy word. So something that just sort of helps you transcend just the everyday stuff. Whether it's music or dance or meditation, long walks on the beach, prayer. There's 100 ways to do it. Everybody can do it personally. And those are really the main ways that almost everybody, including religious people, do it. Religious people have family and friends and work, and so it's a human thing. And so I argue that, us atheists, whatever, we're no different than anybody else. It's just we find our purpose in the same way you do. Now, we don't say, sweet baby Jesus and all that. That's not our thing. Somebody says that, but they're not really, it's a proxy. These religious icons are proxies for other things. Church. You don't go to church, I go to church, how do you get meaning? What do you mean by church? What's going on? So if you deconstruct church, there's a bunch of people that I like. Well, I go out Sunday mornings with my cycling buddies, and these are people I like. So what? Anybody can do that. And of course, they add, free parking. Oh boy, and there's they throw in a little few benefits. It's true, but other groups do that. So that's called social capital. That's important to humans, and everybody does that. So here we are. We're meeting on a Friday night, and we have events on Sundays at Skeptics, and so there's lots of ways to do it.
Thank you.
All right. Another question.
First, I want to say thank you, Dr. Shermer. I discovered the free thought movement, state church separation activism, through my scientific skepticism, which had a lot to do with your endeavors, so I want to thank you for that.
Oh, you're welcome. Thanks for saying so.
What do you think of this hypothesis? It's very brief. The reason there are so many bad ideas out there is because we gain so much more social capital by being polite. The short-term gains are tremendous from being polite and agreeing with those people around us, even when they're batshit crazy.
Yeah, the temptation to say you're batshit crazy is there for sure. I feel it often. I do. But it doesn't work to just say it. Usually it doesn't work. I don't know if that's the driver of bad ideas. It may help perpetrate it. So that's a question of strategy. Do we do the sort of more of a Dawkins Hitchens sort of anti-theism, if you're talking about religion, versus a more modest approach? It depends who you're talking to. Richard's got thousands of letters of people that write him. I read The God Delusion. I'm an atheist now. It changed my life. Great. And when he was on Bill O'Reilly goes, I have 10,000 letters. So what? So, okay, all right, fair enough, so it's not just the number that you get, but again, it depends on who you're talking to. Maybe a different approach works for a different audience. I was at a conference a few months ago at the Electric Universe community. These are the people, they don't believe in gravity. It's like, oh, really? Okay. And Einstein was wrong, and Newton was wrong, and so on. And the whole thing is electric, and science is a closed community, dogmatic, flatlanders. They don't understand the real world, the three-dimensional, like flatland and all that. And what am I doing here? And so they invited me to come speak on the difference between science and pseudoscience. I said, well, here's a good example. But I try to say it in a nice way by how science works. For example, my friends at JPL, tell me who do these calculations for sending a spacecraft to Mars. They use mostly Newtonian mechanics, and they make fine-tuned adjustments with relativity theory. Okay, and so they have all the math there. So I said, so if this is all wrong, gravity's wrong, Einstein was wrong, Newton was wrong, and you guys are right, could you get the spacecraft there more accurately? No. We would do the same math. I said, then what are we talking about? It's just words. Gravity, electrical, call it the invisible dragon gets it there. I don't care what you call it. We're not talking about just words. We're talking about predictable, testable hypotheses and so on. Anyway, so I just try to explain in a nice way, this is how science works, and there's a system in place, because you get these alternative theories of physics, and as I do, and it's like, well, did you publish it anywhere? No, they'll never publish. It's too revolutionary, Well, Einstein was pretty revolutionary. His got published. So how does that work? I mean, apparently it does happen. And, ultimately I'll say, you might go down to the local high school or college physics teacher and just ask them to read that, or just bounce the idea. Just talk to somebody else. Usually people are, in their heads by themselves. Very, very dangerous place to be, because our intuitions about what we think are not reliable. You really need to interact with other people and say, I got this idea. Tell me if I'm crazy. And if they're good friends, they will. I don't know if they'll say you're batshit crazy, but but maybe it's good to hear that once in a while.
So we've already talked about religion, which is one of the things we should never talk about. So let's talk about politics now as well. There is clearly one side of the political spectrum that is struggling to embrace the opportunities that science is presenting to the world. How do you think the scientific community should approach these types of politicians who are perhaps having to challenge their own worldviews when there's a clearly huge benefit of the offerings that we have from the scientific community?
Yeah. Well, I think most of them embrace most of the science. Again, it's only a few things that bump into these cherished values I talked about. So one way to do it is I like Ed Wilson's approach on this to conservatives about conserving the environment. He used the word. It's like, is it in our moral obligation? We're conservatives. Shouldn't we have a moral obligation to conserve the environment? And now there's actually a pretty strong evangelical Christian movement that, that in Genesis there where it says, I forget what the wording is, but, the nature and they're here for us, but doesn't that give us a moral obligation to take care of nature? So there's this strong movement toward this. This is great. Again, it'd be better if we just gave up the whole thing, but that's not going to happen. So let's work with this. Is Sagan's approach. We can't alienate 6 billion people and by attacking religion. So let's get them on board with nuclear weapon, getting to nuclear zero, global warming, and all these big issues. We need everybody on board. So there has to be a strategy for that. So I think that's the approach. We're in this together. We all have different beliefs, but let's focus on solving this particular problem.
Let's do it together.
Do it together, yeah.
Fabulous. Well, I think that's a very good place to end the proceedings. So please all join me in thanking Dr. Shermer again.
Thank you. Thank you so much. That was great.
Thanks,
really good.
Fabulous. Yeah.
Thank you so much.
Yeah.
Thank you.